Hey everyone, today we're going to go over 3.4 Distinguishing Among Atoms, worksheet number 2. It's a lot like worksheet number 1, there are a few differences. So we're going to go over that and explain how to do each and every single question as we go through this. Okay, here we go. Let's go ahead and start off. We have the element name, atomic number, mass number, all these things at the top. We got to know what each one. Now the element name, again, we're going to find those on the periodic table. They're going to be right here on the periodic table. The atomic number, if I go back to that, is the smaller number in the box, as it says up here with the atomic number. Okay, now the atomic number is the number of protons. It also equals the number of electrons, but we always go by the number of protons. So we can say that the mass number is the number of protons plus the number of neutrons. So we have to add those together. Okay. So if we want to get the number of protons, we can go back to the periodic table for oxygen, and that would be 8. So I can go ahead and put 8 right in here. We also know that that equals the atomic number. Then we go to the number of neutrons. We're going to take this right here, 17, the mass number, and we're going to subtract the number of protons. So I'm going to go over here and I'm going to grab a calculator. And we're going to put that calculator right up here. Oops, pull it back again. And so I have my calculator right here. And so we're going to go ahead and take our 17, or subtract 8 from that, and that's going to equal 9. So that's going to be the number of neutrons. So put the number of neutrons right there, 9. The number of electrons is always the same as the number of protons because they have to be equal but opposite. So we're going to go ahead and put our number 8 right there. Now the isotonic notation is probably a word that you haven't heard yet. Well, that is basically our symbol with the number with the atomic number on the top of the superscript and the mass number as the subscript. So we're going to go ahead and put this in here, and we're going to get to our superscript first. So if you remember how superscript, you're going to hold down the control, and we're going to do greater than. And our superscript is going to be 8, because that's our atomic number. Then we're going to go right straight to our subscript, which is going to be the mass number, which is this number right here, 17. And then we're going to go back up by hitting the control and then less than again, and that gives us our symbol, and our symbol for oxygen. If I go back here, oxygen is right here, and it's O. So let's go back there, and let's put a capital O in there, and there's our first row. So let's go to the next one. We have atomic number of 15, which atomic number is the same as the number of protons, so I can put the number of protons, 15 there, which is the same as the number of electrons, and we'll put 15 there. Now I got to subtract the 2 right here to get my number of neutrons. So we're going to bring back up our calculator, and we're going to take 31, and we're going to subtract 15 from that, and that's going to equal 16. And so we're going to put 16 right there. Well, now, what element is this? Atomic number 15. Well, let's go back to our packet. Let's find 15. 15 is right here. It's phosphorus. So we'll go back in here, and we're going to write in phosphorus. And I got that horrible spelling. So let's go back and look at the number, how to spell again. P-H-O-S, P-H-O-R-U-S, P-H-O-S, P-H-O-R-U-S. All right, I just got it right there. Okay. And then we're going to go all the way over here. So we know that our scientific notation is P. So we're going to go with our first one. The atomic number is 15, so we're going to put down control down, and we're going to do greater than. It's going to be 15. Hold control greater than, or less than, excuse me, and we're going to be 31, and then hold control down again, and then less than, and then now we're going to put a capital P in there, and there's our isotonic notation. So let's go on to the next one. The next one we have 38 is our atomic number, so that's the number of protons, 38. It's also our number of electrons, 38. Our number of neutrons is 50, so we're going to add these two together. So we can bring up our calculator if we need to. Okay, we can go 38 plus 50 equals 88. So we're going to put 88 right there. Okay, so now let's go over or do the element name. We're going to do atomic number 38. So we're back to the periodic table. Atomic number 38 is right there, strontium. Okay, so we'll go back to this and we're going to put in strontium. Okay, and we know that that is SR. So we do our atomic number, which is going to be, again, control greater than 38, control less than 88. Okay, because that's the mass number. Control less than gets us back up to our normal, and then we have capital S, lowercase r. Let's double check that again for strontium. Strontium, capital S, lowercase r, and we're done with that one. So let's go on with neon. Here we have the mass number of 20, but let's go ahead and do the rest of them. Neon, let's go over here to the periodic table, find neon. Neon is right here, so its atomic number is 10. So we're going to put a 10 right in here, which means the number of protons is also 10, which means the number of electrons is also 10. And in order to get the number of neutrons, I have to take the mass number, 20, subtract 10 from that, and we know that that's going to be 10. So let's go, we need the symbol for neon. So it'll be for the last one, neon, the symbol is capital N, lowercase e. So let's go back over here. So the atomic number is going to be, remember we're going to do control greater than, then we're going to put a 10, control less than, and now we're going to put our mass number, which is 20, and control less than gets us back up, capital N, lowercase e. There's neon. Okay, let's go to the next one. We have the number of electrons, which is also equal to the atomic number, 9, which is also equal to the number of protons, 9. Okay, in order to get the mass number, I have to add protons plus neutrons, so I add those together. That is 19. And now I know what that element is. I think it's fluorine, but let's go ahead and double check it. We have 9 for atomic number and 19, fluorine. So let's go back to the here. We're going to put in fluorine. Okay, a lot of times I put fluorine. So let's double check, make sure we spell it UO. Okay, it's all correct there. So we're going to come back over here. We know the symbol is F, but our atomic number is 9. So we're going to go control greater than 9, control less than 19, control less than gets us back to normal, and we put a capital F for fluorine. Okay, let's go to the next one. Number of protons is 79. The number of neutrons is 118. So we're going to come over here to the atomic number, which is also equal to the number of protons, and we'll put 79, which is also equal to the number of electrons, which is 79. The mass number is the number of protons plus the number of neutrons. So we're going to go pull up our calculator again, and we'll put 79 plus 118 equals 197. Now, hopefully you already know what element this is. I do. It's gold. So let's go ahead and go back to gold. Here it is. AU, gold. Yep. So it is gold. So let's go back, put in here. We're going to put in gold. Well, the symbol for gold is AU, but remember, the atomic number is 79. So we're going to come in here and we're going to put control greater than 79. Control less than is going to be our mass number, which is 197. And then we're going to control less than again and put our symbol for gold, which is A, capital A, lowercase u. Okay, we're done with that one. Okay, let's go to the next one. It says identify the neutral atom, description by name, and mass number. So an atom with 2 neutrons and 1 proton, we're going to say right now it is going to be hydrogen. We know that it's hydrogen. Okay, by its name, and then its weight is the number of protons plus the number of neutrons is our mass number. It's going to be 3. Now we could also put tritium, which we know right off the bat is already 3. That is just an isotope of hydrogen, and it's a named isotope. But if we want to double check with the first one, hydrogen 3, go to the periodic table. We see hydrogen, 1 proton. We know that that's it. But a normal hydrogen would only have a mass number of 1, so that has 2 extra neutrons. So let's go to the next one. We have 18 neutrons, so we have 18 neutrons. Let's find 18 neutrons. That is argon. So we're going to go back, argon. Put argon. Now, what is our mass number? Well, we're going to add those two together. So let's go back to our here. 18 plus 17 equals 35. So that's going to be argon 35. Now, one thing we're going to look at, you might want to look at, is when I look at argon 35. Let's go ahead and look at argon. Argon is 40. Now, that's a lot less, okay, than, so normally a normal one would be 40, but if we have less neutrons, which is fine, it's just going to weigh less. That's all there is, okay? So let's go ahead and go to the next one. We have 6 protons and 8 neutrons. Oh, excuse me. Yeah, on this one up here, I misread this, but remember, that's the number of protons. So let's go back and find the number of protons, because I think I made a mistake on this one. So let's get rid of this one. Let's go back. I have 17 electrons, which means I have 17 protons. So let's go back. 17, that's chlorine. Good thing we double check those things. So that's chlorine. And then we can add those together. And now we add those together, and that was 35. There we go. That's the correct one. Let's look at the next. We have 6 protons and 8 neutrons. So 6 protons, 6 is carbon. Okay. So we're going to break down carbon. Then we're going to do the mass number, which we're going to add those two together. So 8 plus 6 is 14. So we have carbon 14. Now I can go ahead and do that in the calculator. 8 plus 6 equals, 8 plus 6 equals 14. Okay, let's go on to the next one. Number 4. Answer each of the following using your knowledge of the periodic table of chemistry and the periodic table. So an atom that contains 55 proteins, what is it? Protons. What is its symbol? So let's go to the periodic table and let's find the one that says 55 right over here. 55 cesium. So capital C, lowercase s. So we're going to put in capital C, lowercase s for cesium. An atom that contains 31 protons, 39 neutrons, and 31 electrons. Identify the mass number of this atom. Well, the mass number is going to be the number of protons plus the number of neutrons. Okay, so if I take this one and put it over there, I have 40 plus 30 is 70. So we know the mass number is 70. But let's go ahead and identify what it is. 31 protons. So we have 31, so it's gallium 70. So one way to write this could be gallium A 70. Okay. Let's go on to the next question. What is the atomic number of bromine? Bromine. So we're going to go to the packet here. We're going to find bromine. It's right over here. The atomic number is 35. Again, the atomic number is always the one that's lowest in the box. So let's go back over here, and we can write in 35. What is the number of subatomic particles in an atom of B11? So B11. So B is that's the mass number, and this is the symbol. So let's find B. We have boron. So I know that I have 11 protons and neutrons together. Plus, we're going to add the number of electrons because the question said how many subatomic particles. So we have to count the electrons. So 11 plus 5 is 16, and that would be your answer. So what is the atomic number of Zn65? So all we have to do is look at the atomic number for Zn, which is zinc. Go in here. Zinc is 30. So we go back. And so the atomic number for zinc is 30. So how many neutrons are in an atom of hydrogen 201? Okay, we know this is the mass number. So we're going to go ahead and look at mercury, right? Mercury 201. And I have 80, so I'm going to subtract these two numbers. So I'm going to go back to this over here, and I'm going to hit my calculator, and I'm going to take our 201, and we're going to subtract the atomic number, which is the number of protons, which was 80. Hit my enter, And I know that there are 121 neutrons. Okay, let's go ahead and we're going to highlight their answer on the rest of these. Number 10. All atoms of the same element must contain the same number of, this is your correct answer right here, protons. What is the total number of protons in the nucleus of magnesium? 23. So let's go ahead and find magnesium. It's asking for proton. There's magnesium. This number up here is the number of protons, so it's 12. So let's go back to our correct answer. We'll find the correct answer is C12. Let's go to the next one. Isotopes of a given element contain the same number of neutrons but a different number of protons. Nope, that'd make it a different element. The same number of neutrons and protons. Nope. The same number of protons but a different number of neutrons. That would be our correct answer. So we'd highlight that one right there and change the color. Now the same number of protons but a different number of electrons. No, it's going to have the same number of electrons as it does protons. But what makes it isotope is they'll all have the same number of protons, but they all have a different number of neutrons, which makes it weigh a little bit different. Okay, 13. An atom with 29 protons and 36 neutrons is an isotope of what element? Well, all we have to do is look at the number of protons and look at our periodic table. We have 29 protons, which is our atomic number. 29, that's going to be copper. Doesn't matter what this number down here is. So we have copper. So we'll go back to our answer. Copper is the correct answer. Highlight that. And we're done. Okay, on to 14. Carbon exists as 3 naturally occurring isotopes, carbon 12, carbon 13, and carbon 14. As the number of neutrons increase in the isotope, the nuclear charge does what? Well, remember, we're adding neutrons, not protons, so the nuclear charge remains the same. Okay, doesn't matter which one of those, how many more neutrons we add, because neutrons have a 0 charge, so it remains the same. 15. An atom of an element is electrically neutral because the number of protons equals the number of electrons, the number of protons equals the number of neutrons, the number of neutrons equals the number of electrons. Well, which neutrons don't have charges? So they don't have to equal anything. So that one and this one's off. So this one must be the correct answer. Process of elimination. But if we look at it, the number of protons always has to equal the number of electrons when we have an atom. Remember, if it's an ion, it's different. Okay. What is the nuclear charge of an atom of nitrogen 14? Now here we're talking about the nuclear charge. Okay, 14, 7, 0 plus 6. Well, let's find nitrogen and see what its atomic number is. That atomic number tells us how many protons are in the nucleus, and since protons have a charge, those are the ones that we're looking at. We know that overall it's neutral, but that's when we can include the electrons in the electron cloud. But here they're only asking about nuclear charge. So let's go ahead and find nitrogen. Nitrogen is right here. So the atomic number is 7. So that's the number of protons. So we can go ahead and see the overall charge, positive charge, is positive 7. Not a question that I like to answer that way, but hey, it is a good question and valid for when you figure out how to do things. Hey, that's how we do 4.3, Distinguishing Among Atoms, worksheet number 2. If you have any questions, don't forget to ask them in class or in Google Meet when we meet there. Hey, as always, go Mohawks. Nelson out.